Yeah, so I was hoping to make a longer video where I go into the performance testing of the Dynaco Mark IIIs. I bought a new audio analyzer so that I could do some additional tests beyond what my existing Panasonic VP7725 can do without having to write custom software. And I started running some tests on it, and unfortunately it broke a couple days after I got it, so I'm pretty disappointed about that. But I figured I'd share some of the video that I recorded, and they're not very thorough or exhaustive tests, but some people might still be interested in them. So if that sounds interesting to you, stick around. Oh, and one more thing. At the end of the video, I'm going to talk about my next project. So if you're interested in things like Dynaco Tube monoblocks, stick around because I bet you've never seen one of these before. Here's a little teaser. So I was hoping to make another video where I really went into the weeds on performance testing these amplifiers, doing things like THD versus frequency sweeps, power versus distortion sweeps, other things, IMD, and I bought a new audio analyzer to help me with that. I bought a Rohde & Schwarz UPL. I've wanted one of these for a while, and there's a lot of other reasons I wanted this that I won't go into in this video. Unfortunately, this thing showed up on Tuesday. It worked on Tuesday. It worked on Wednesday. I was finally starting to get the hang of it. I come home from work on Thursday, all excited to use it and start really getting into it, and it no longer boots. So I'm really sad about that. I was really looking forward to using that to show off some of the things that I found with these Mark IIIs. You know, one thing that I did notice with these, and I think I actually recorded this, so maybe I'll share it on the screen, is that those tubes, those Lin-Li tubes, the one that I suspected was kind of funky based on the bias drifting, it actually seemed to have somewhat high distortion below 100 hertz, and I was hoping to run that sweep again with different tubes in there to see if it went away when the tool died on me. So that's kind of where we're at. Alright, let's talk about the tubes. You just heard me mention the Lin-Li tubes and a bias drift issue. So ultimately, I do think one of the Lin-Li tubes has an issue that causes the bias to move around on it. If you remember back to the first video, he mentioned that he had that problem where the bias would drift up after the amp was on for a while. Now, it does take a while for these amps to warm up and for the bias to settle down, so that's somewhat normal, but I spent quite a bit of time swapping these tubes around between the two amps, and I got it to the point where I noticed one amp seemed rock solid and the other one had the issue that he described. So after shuffling them around some more, it did seem like it followed at least one of the tubes on the serial number ending in 37. I also am slightly suspicious of 39, but it was getting to the point where I was spending way too much time on it. So I ultimately had a third set of tubes here, and when I put them in, they held their bias rock solid. The other thing that I noticed was the Lin-Lis, they seem to take a lot longer to come up to the bias point after you power the amps on than the other two sets of tubes here that I had. So I'm confident that the electrical work in the amps was good. And then the next thing I did was I tested all of the tubes. I tested them on my TV7 tube tester first, and you'll see the reading in the second column there. As a reminder, 44 is the minimum good for a 6550 or a KT88. And then the next thing I did was I tested the plate current on the Tektronix 570 curve tracer. Now, I just picked that up a few months ago, so I'm still learning the ins and outs of it, but I'm pretty sure I got it right. And what I noticed was the Lin-Li tubes, they came with a little card showing the test conditions and what they measured on plate current for them. And they mentioned that they tested them at 450 volts plate and negative 55 volts of bias. So I figured that was a good starting point. So I measured the tubes on the 570 at that point, and these are the numbers I came up with. So you can see that the Nestone tubes, the 6550s, they're badly mismatched. And the interesting thing is that they were pretty close. Two of them were pretty close on the curve tracer, the 82 and the 84, but the plate current in milliamps was off quite a bit between them. And the Lin-Lis, they were fairly well matched. And if you look all the way at the right, so what that column is on the 570, and I guess I'll try to make a video using the 570 one day when I feel a little more comfortable with it. That was the number that I got if I basically looked at the curves and I figured out what bias voltage I needed to achieve 70 milliamps at 450 volts. And I validated that after the fact by putting the tubes back in the amplifiers and checking the plate current there, and my numbers on the 570 did match what I was seeing in circuit. within reason, of course. I mean, I don't have the bias balance control on these amps, so I couldn't balance it out perfectly, but I'm pretty confident with those numbers, so it seems like a good way to be able to match tubes. So I've got a frequency response test running. If you look at the analyzer page, I set it to the 110 kilohertz analyzer so that we can see the harmonics for the higher frequencies. And it looks like the left channel's got more distortion around 20 hertz than the right, which I think could be due to that weak pentode section in the driver tube. It's my best guess. So we'll try a different driver tube. I zoomed in a little on the low end here. I'm going to change the steps from 1 kilohertz to 50 hertz, and let's tell this to run again. See where that stops. Let's go here. Try to remember how to zoom. There we go. Still learning how to use this thing. So it's only at the really low frequencies that seems to be a problem. I'm still curious to see if a different 6A and 8 helps that though. Alright, so I swapped out this GE 6A and 8A that had on my TV7 it measured 52 triode, 38 pentode, with a new old stock RCA 6A and 8A that I had that I don't remember what it measured. I measured it a while ago and I remember both sections were strong. So anyways, I already ran the test, and as you can see, it seems to have resolved that issue with the low frequency distortion. And this is at 500 millivolts signal, I believe. Let's see here, Alt G for generator. Yeah, it's 500 millivolts. I can put this to 1 volt and let's run it again. Right, as a reminder, the 1.55 to 1.58 or so is our full power. So Alt R, turn the generator on, is F11, F5. It'll take a minute. Yeah, that's looking a lot better. Question is, which color is which? I'm not sure. Like I said, I just got this thing yesterday. Alt D for display. It doesn't show you here. Let me just unplug the left channel from the analyzer and see which line goes way up. So the green is the left channel. That's kind of interesting that the RCA tube seems to be higher distortion in general than the GE, even though it doesn't seem to have that bump to over 1% around 20 hertz like this weak GE did. For that last bit of video, after the recording stopped, I noticed that the distortion started to creep back up again as I continued to play around with the tests. So it doesn't seem like it's related to the driver tube after all. I still suspect that it's related to the one Linlai KT88 that I suspect of having a bias drift issue. So it would have been cool to run that test again with a different set of tubes in there, but unfortunately the UPL analyzer died the next day. It was still interesting to see that the RCA 6AN8 had a slightly higher level of distortion than the GE one though, so hopefully I can get the analyzer working again, because it seems like it would be a lot of fun to run tests like that on different tubes. In this test, we'll be testing THD plus N on the amplifier. I'm going to start at 500 millivolts of output signal from the analyzer, and this is terminated into 600 ohms because that's what this analyzer needs to see for that number to be somewhat accurate. The Mark III is rated 1.6 volts RMS to full output, so I'm going to turn this on at 500 millivolts and we'll step it up. So at 500 millivolts we're at 5 watts, 0.4%, and this is with no filters on. It's common to see A weighting filters specified when testing this. All right, let's go to 800 millivolts. 800 millivolts, we're at 13 watts at 0.07%. Let's go to 1 volt. So at 1 volt, we're at 20 watts at 0.09. And 1.1, 24 watts at 0.13. 1.2, 29 watts at 0.17. 1.3 is 34 watts at 0.22. 1.4, 39 watts at 0.27. 1.5, 45.5 watts at 0.31. And 1.6. 1.6 we get 51 watts, and you can see the distortion creeps up to just under that 1% that they specify. So I'll back it down a little bit and get it exactly on 50. So 1.58 volts at 0.5% distortion with these tubes. And again, these driver tubes in these amps are not perfectly matched. This one actually has a weak pentode section according to my tube tester. The owner of the amp has some new ones on the way that he's going to try tube rolling with, but it still beats the rating. The rating is 1% distortion at full power, which is 50 watts. So I'm happy with that. Alright, we're going to test the signal to noise ratio of one of these Mark IIIs. So I've determined that 1.58 volts output from the audio analyzer creates 50 watts of output from the amplifier into an 8 ohm load. So I've got the analyzer source set to 1.58 volts, and that's terminated into 600 ohms because that's what this analyzer likes to see. And then what I do is I hit the signal to noise ratio button, and it runs the test. And it's saying 92 point something dB, 91, 92 dB. Now the interesting thing is this is with no filters turned on at all. Most manufacturers specify the signal to noise ratio with an A weighting filter turned on. So if I turn the A weighting filter on, you'll see the number improves even more. So I'm not sure what to think. 92 dB is great with no filters, and we did improve a lot of the components in this, all low noise metal film resistors and things like that. So either way, I'm happy with it, but it would be nice to know if Dynaco would specify which testing methodology they used back then. Because on my other audio analyzer, the new one that you see sitting down here, the Rohde and Schwarz, if I do a signal to noise ratio test on that, it actually yells at you if you don't turn a filter like the A weighting filter or a high pass filter on, and says you have to do that when doing the signal to noise ratio test. So let me know if you guys have any feedback on that. So I thought this was pretty cool. I've been playing around with Python and GPIB to control my instruments, and a while ago I wrote a script that could do some tests on my Panasonic analyzer, such as distortion versus power level, and I took that one step further and I connected my HP 34401A multimeter to the GPIB bus as well, and I monitored the plate voltage of one of the tubes using a test socket adapter, and you can see in the chart that the plate voltage drops as the power level goes up. I mean, that's something that is pretty well known, but it's interesting to see the correlation between that and the distortion and power level all at the same time. Okay, let's take a look at the difference in level between the two amplifiers. So this is my new Rohde and Schwarz UPL audio analyzer that just came in yesterday. So you'll have to bear with me as I'm not totally familiar with its interface yet, but I've been picking it up. So they had a built-in program called, let's see here, level difference DUT channel 1/2. So we're going to load that program. That sets our settings. And then we're going to go to the generator page. I've got to get some cabling for this, but I've got it rigged up for now. Change the output to unbalanced. Then we want to set our generator voltage to, I'll do 1.55 volts, so that's near the 50 watts that we're getting out of these guys. And let me get rid of this panel for a second. So then on the analyzer, we're going to leave that pane alone. And then on the display, this is how you get the graph. It's basically showing the difference between channel 1 and 2 using channel 1 as a reference. So the difference will be the value shown. So let me get that back on the screen. I'm going to change the scaling actually, so it's Alt-D for display. I bought a UPL 66, which does not have the front panel LCD or controls, which isn't really such a bad thing because I kind of like having them down here on the bench anyway instead of reaching up over my head. This interface is not easy to use. So we're going to set the spacing front. They have it at 10 to negative 10 dB. We're just going to set it between 1 and negative 1 dB because I already have an idea what this is going to do. So I'm going to turn the generator on, which is Control F11, and then we will hit Control F5 to start the sweep. You can actually hear it through the transformer. I can stop this at any time. So basically we can see we are at less than 0.2 dB difference. This is from 20 hertz to 20 kilohertz. Less than 0.2 dB difference between the 2 amps. So that's looking pretty good, especially considering that the driver tubes aren't matched very well to each other and balanced between the triode and pentode section. And again, this is around 5 watts from 20 hertz to 20 kilohertz. Let's go ahead and scale. So that's 100 hertz where the marker is right now, just to give you an idea of what 20 to 100 looks like. And these tests have all been done with the Lin-Lai KT88 tubes, and they're biased on a little bit on the cool side. We also discussed a few other changes that he could make in the future if he wanted. The only thing we didn't change in the bias circuit was the original potentiometers. I cleaned them and they seemed to test okay, but if this was mine, I'd probably spend the money and put some of these mil-spec RV4 potentiometers in there. You can get this model shown on the screen, which is the short locking shaft. Now the locking part's unnecessary for these amps, but those will last you forever. And then the other mod that we talked about was the bias balance kit. since he doesn't have an easy way to test individual tube bias while they're in the amp without flipping it over and taking the bottom off and connecting multimeters and things like that, this is a good solution that could help him in the future if he doesn't have perfectly matched tubes. And it's only like 25, actually it's probably a little more than that, I forget what it costs, $25 to $40. But those are for another day. Alright guys, so here's the next project. We've got a couple Stromberg Carlson AP437 power amps. Now what's special about these is, at least two of them, there's three of them here, here's two. Here's the other one. Two of these are brand new. Well, they were brand new a few months ago. I was originally chatting with the guy about doing the work on these, but he's about 2 hours away and he found someone closer. The other thing is he wanted to try to maintain as many of the original parts as possible, including the original filter capacitor. So he found someone that supposedly reformed and leakage tested the capacitor, which I don't agree with doing on these. These things are 70 years old. These can capacitors had a lifespan, at least according to Hewlett-Packard and some of their documentation, of only 5 years when they were new. And I won't do work on an amp like this unless I do it a way that I'm comfortable with and I can stand behind, which includes replacing this. So he took it to another tech and he got them back, and I guess what happened was he was playing them one night and all of a sudden he noticed some sparks in the rectifier tube, and then these amps have circuit breakers instead of fuses, so the circuit breaker popped. So he grabbed another rectifier tube, and these are brand new tubes actually. I have them here in this box. They're all original Stromberg Carlson branded 6550s. They're Mullard GZ34s, and supposedly that one sparked as well and popped the breaker again. And at that point, I said, why don't I take a look at him? Obviously, the last guy didn't know what he was doing or didn't care, because it's totally irresponsible to give these back with the original filter can in there. He also left some of the paper caps. He didn't change the bias circuit at all. The original electrolytic is in there. So the good news is I tested all of his tubes, and they all seem to be pretty healthy. So I didn't see any shorts or anything on the rectifiers. The power tubes are good. Right now, I put JJ rectifiers that he had in and some Electro Harmonics KT88s. So we'll get them going on the cheaper tubes before we put the originals in. Those original tubes go for a lot of money. Oh, and another cool note, apparently Stromberg Carlson was into really high-end stereo consoles in the 50s and 60s, and the console that these amps would have been used in apparently retailed for $4,800 in 1961, which adjusted for inflation is $51,000. Isn't that crazy? So if that sounds interesting to you, subscribe to the channel, and I'll probably have the next video on these in the next week or so.